The second half of this section deals with coordinate proofs. And so far we've dealt with only two-column proofs where you have a statement and a reason. So you put all your statements on the left-hand side, you put all your reasons for it on the right-hand side. The coordinate proof is a little bit different. But that's when you place your shapes on a coordinate plane. And so we're going to place shapes like this triangle here on a coordinate plane, and we're going to assign coordinates to it. We're going to assign coordinates to it. And sometimes we use numbers, but sometimes we use variables like x and y and a and b and so on and so forth, so that we can say, in general, it's a rectangle, but it can be anything it wants to be. It can be a, so it can be any number, positive or negative. And so in that way we can prove things about triangles, whether, hey, are all these sides going to be the same, or are the angles going to be right angles, or do the diagonals cut across each other? And so part of our first practice is going to be, how do we put shapes in the coordinate plane to be helpful? So first we want to place this isosceles right triangle in here. So isosceles, two equal sides, and to make it be a right angle, the easiest way is to use the x and y axis, because that's a perfect right angle for you. And then use the corner. Always try to use 0, 0 because it makes it easy to find the distance. And then we want the length to be 3 units. So I went straight to the right and I went straight up. You could have flipped your triangle over and it could have gone to the left, it could have gone down, it could have gone to the right, and down. Any options. Usually we choose going to the right because it's got positive numbers that way. And then we have a square. Again, use the x and y axis to your advantage. Don't go and put a square on its side just because you can. 0, 0 makes everything easier. So we can go to the right 5, we can go up 5, and then this top right corner would be 5, 5. Keep in mind this point over here is 5, 0 because you went to the right 5 and didn't go up or down. And then this one you didn't go left or right, but you went up 5. So it's 0, 5. So our first taste with variables. Now, find the unknown coordinates and then show that the given statement's true. So the first one we don't know is this over here. This point right here, this point C, is 0, k. We didn't go left or right, but we went straight up k. And we're going to assume that this one is at the same level. This has a k value and this has a k value, so this one's going to have a k value. And this one has an x value of negative h, so we've gone h to the left, and so this point's right above it, and so we're going to put a negative h right there as well. So negative hk is that point. Now, to show that the given statement is true, what we have to do is think about last chapter stuff, and we can prove things by side, 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 right? So if I can show all three sides are the same, and this is where distance formula or Pythagorean Theorem is going to come into play. And so from here, let's find this side length. To go from negative h to 0, I go h, from negative h to 0. Or you could think negative h to the left, but distance is always going to be positive, and so that's why I just put h. And because we stayed at the same level k, we don't have to think, let's subtract those. The same thing goes with, if you have points on the number line, the difference between negative 5 and 0 would just be 5. You don't have to do any fancy distance formula because it's on a number line. You haven't changed in the y. And then to go from k up and down to 0, we've gone k up or k down. And so we have two side lengths here. Notice over here that you also have an h and a k, because we went from x value being 0 right here to the x value being h right here. So this side length is h. And so I marked this congruent to my h over here, so we've got one side, check. This k, we went from k to 2k. And that difference is 2k minus k, and so that gives us a k right here. And so I marked my k sides congruent as well. So from 0 to k and from k to 2k, both lengths are k. Now, those were both horizontal and vertical, and so those were very easy to find. But this diagonal one is going from 0, k to h, 2k. And so we have to find the length of the hypotenuse. And for that, I'm going to use Pythagorean Theorem, which is a squared plus b squared equals c squared. And sorry, so we made our k's equal, and so we have our second side. And so h is going to be my a, and k is going to be my b. And so h squared plus k squared equals whatever this is squared. So then we take the square root, and so our distance is h squared plus k squared. Which, be careful, do not say that this is equal to h plus k. You cannot distribute your square root. And I'll just show you a counterexample real quick. 4 squared plus 3 squared is not equal to 4 plus 3. The square root of that, because this is 16 plus 9, which is 25, which is not equal to 7. The square root of 25 is not equal to 7. And so we have the square root of h squared plus k squared, and then the same thing happens in the other half of this triangle. You get h squared plus k squared, h squared plus k squared. And then you take the square root, because they have the same side lengths, so they get the same hypotenuse. So those two triangles are congruent by side, side, side. Now, last one. So we have this point at 0, 0. And then these 3 points right here all line up right below each other. And so they all have the same x value because they haven't gone left or right from each other. And so this h, negative h, is also the x value for this point down here. And that point down here has a y value of 0 because it's on the same line here. It's on the x-axis. So then you go straight up, same x value, right? Negative h, negative h, negative h. And I chose to double this one because this was 0 and this was 2k. So I said, well, let's make that another 2k. So if this is 2k, this is 2k, so that makes 4k up there. And then that has the same y value as well to make that 4k. And that is coordinate proofs. And so what you're going to have to use also in this is the midpoint formula. Midpoint formula is where you average the x and you average the y. And so to do that, you're going to do x plus x divided by 2. That's how you find the average of two numbers. And you do the y plus the y divided by 2. And that's how you find the average of two numbers. Now, we usually put subscripts here so that you know you're talking about two different things. And then we also talked about the distance / Pythagorean theorem. The distance formula. The distance formula is x minus x. You subtract them, and that essentially finds you your a value of your triangle. And your y minus your y finds you your b value. And then you square them. Oops. And then a squared plus b squared equals c squared. And so this is equal to your distance, whatever it is, but then we take our square root of both sides, and that's where the distance formula comes from. But it's really the same thing as the Pythagorean theorem. Coordinate proofs. Have at 'em.